Hey everybody, welcome back. We are here today to talk about linear graphs and equations. This is a new unit and this is part 1. We are going to talk about graphing points and slope of a line. Let us review graphing points on an XY coordinate plane. You may recall that when you graph a point, you always go either left or right first and either up or down second. You may ask, why do we go left or right first and up or down second? Well, let's say you lived in Georgia and you moved to somewhere like Louisiana or Wisconsin or even Arizona. You would get a new teacher like Mrs. Waller in Phoenix, Arizona. And I guarantee you, Mrs. Waller would go either left or right first and up or down second. Let's use our old buddy Steve to help us graph this point. You should know that negative means left, and we're going to go left 4 spaces. Steve goes 1, 2, 3, 4 to the left. In the second position, a positive number goes up, a negative goes down. So Steve goes up 1, 2 spaces. Thank you, Steve. So the point -4, 2 describes this point right here on the plane. Hey, this is math class and we do problems. Let's do number 1. Keep in mind, if we are working these problems at either Socrative or Google Forms, and I talk about number 1 in the video, I mean the number in the upper left-hand corner. Let's once again use our old buddy Steve to help us graph the point 1, 4. Let us put Steve at the origin or the beginning. He would go right 1 and up 4. The answer is D. So for number 1, put choice D and you will get it right. Number 2 is just as easy. Let's put Steve here. Steve would go left 2, down 1, and the answer is choice B for number 2. Number 3, what are the coordinates of point A? From the beginning or the origin, we would have to go left 3 spaces and down 1 space to get to point A. So the answer is the coordinates -3, -1. Let's head over to Socrative and make sure we type this in correctly. Here we are at Socrative where it says in problem number 3 in the video, we identified the coordinates of a point. What were these coordinates? The coordinates of point A are -3, -1, but make sure you follow these directions. Do not write a sentence and input the coordinates only. Also, do not hit the space bar. So we type open parentheses -3, comma, -1, close parentheses, no spaces please. Make sure you follow those directions at Socrative to get it right. Number 4, what are the coordinates of point A? Let's put Steve at the origin. He would just go 2 spaces to the left. He would not go up or down. Therefore, the coordinates are -2, 0. You have to have the parentheses with no spaces. We are here today to discuss lines. Remember, lines are infinitely thin. It takes exactly 2 points to define a line's direction, but there are an infinite number of points on every line. Let's use Steve to talk about positive slope. If we put Steve on the far left portion of the line and move him across the line, he is going in an upward direction. That's positive slope. You might think, well, if we reverse him, he's going down, and that would be negative slope. But that's just not right. We read lines left to right, and as he goes left to right, it goes up. Once again, let's use Steve to describe negative slope. As a line moves from left to right, if Steve were to go downhill, the line would have negative slope. If we were to talk about zero slope and move Steve across the line from left to right, it doesn't go up or down. This line has a slope of 0. In a vertical line like this, it does not move from left to right. It only goes up and down. This slope is undefined. Number 5, which 2 graphs have a line with positive slope? Let's use Steve to help us out. This one goes up from left to right. Check. This one goes down from left to right. No good. This one, as it goes left to right, is flat. That's a slope of 0. Choice D, as we go left to right, it goes up. That is our other answer. Let's verify E. As we go left to right, it goes down. As a result, for number 5, we have to put both A and D to get it right. Ultimately, we want to talk about equations of lines, but before we can do that, we have to continue our discussion on slope. The slope of a line is the ratio of a line's vertical change in direction to its horizontal change in direction. Number 6, what is the vertical change in direction of line L from point A to point B? Once again, let's use our imagination, which we have named Steve. The vertical change in direction is how far Steve would have to walk up if he were walking from A to B along the grid instead of walking from A to B in a direct path along line L. And since he walked in an upward direction, we are going to say that that is +1, not -1. Number 6 is A. Number 7 is the same line, but this time it is asking what is the horizontal change in direction of line L from point A to point B. Once Steve has walked up one space to get the vertical change in direction, he would then walk 1, 2, 3 spaces to the right to get the horizontal change in direction. And since he went to the right, we are going to say that that is +3, not -3. Number 7 is B. Number 8 says, what is the slope of line L? Remember, the slope is a ratio of a line's vertical change in direction to its horizontal change in direction. We found the horizontal change in direction was 1, the vertical change in direction was 3, and the ratio of vertical to horizontal is 1 to 3 or 1/3. That makes Steve and myself very happy. Number 9 is a new line, and we want to know its vertical change in direction from point A to point B. Let's put Steve at point A. Remember, we are not walking along the line. We are walking along the grid, and Steve goes down 1, 2, 3 spaces. And since he went down, we're going to say his vertical change in direction is -3, choice E. Number 10 is the same game, except this time we want to know the horizontal change in direction from point A to point B. Steve has already gone down 3 spaces. He is awfully tired, but he's ready to go to the right. And his horizontal change in direction is right 2 spaces. We know right gives us a positive value. The answer is A. Number 11 puts the previous 2 problems together, wanting the slope of line L. Slope is the ratio of a line's vertical change to its horizontal change in direction. In this problem, Steve went down 3 spaces, which gave us a vertical change of -3. He then went right 2 spaces to give us a horizontal change of 2, and the answer is D, -3/2. Okay, we are beginning to know all about vertical and horizontal changes in direction and how they interact to form slope. In number 12, it looks like we're going backwards. Let's do the vertical change from A to B. It is down 1, 2, 3 spaces, which of course is -3. After going 3 spaces down, now we're going 1, 2, 3, 4, 5, 6 spaces to the left to get the horizontal change in direction, which is -6. In number 14, we know the slope of line L is its vertical change in direction to its horizontal change in direction. The vertical change in direction is -3, while the horizontal change in direction is -6. The fraction -3 over -6 reduces to +1/2. The answer is C. Remember, it makes a whole lot of sense that the answer is indeed positive. If we put Steve on line L and move him from left to right, he goes in an upward direction, and up is positive. Number 15 looks tricky. Let's see if we can handle it. We want to know the vertical change from point A to point B. If we just count the grid, it's 1, 2, 3, 4, 5, 6. But wait a minute, the y-axis is not scaled by 1, it's scaled by 25. Yes, by the grid, Steve is going up 6 spaces. But by the scale of the y-axis, he is going up 150 spaces. Man, that's a long way. So the answer to number 15 is E. Number 16 is the same game. We have to look at the scale on the x-axis. Instead of thinking Steve going 1, 2, 3, 4, 5, 6 spaces, we could count 1/2, 1, 1.5, 2, 2.5, 3. So the answer to number 16 is C. In number 17, we want to know the slope of line L. The vertical change is 150. The horizontal change in direction is 3. 150 divided 3 is E50. Number 18, which would be an interpretation of the slope of line L? Before we decide, let's talk about the word purr. I have a cat named Felix, and he likes to purr, and it always makes me really happy. But that's the wrong purr. In this case, purr literally means to divide. And slope is the vertical change in direction per the horizontal change in direction. The vertical change in direction occurs along the y-axis, and the horizontal change in direction occurs along the x-axis. We want to think of this as the y-axis per the x-axis, so the answer is A, miles per hour. Number 19 is the same game. Acres is along the y-axis, and deer is along the x-axis. So the answer is A, acres per deer. Before we go, I want to talk about lattice points and using them to find slope. Lattice points are points on a regularly spaced array of lines and are usually integers. In number 20, how many of the points appear to be lattice points? Point B is clearly not lattice. We might want to think of its coordinates as 2.5, 4. 2.5 is not an integer, and B is not lattice. Point A looks awfully lattice to me. Its coordinates are -3, 4. Both coordinates are integers. You should be able to see what we're looking for. We want the points to be on the grid. C is a lattice point. D is not a lattice point. It's on neither part of the grid. E is not lattice. It's only on one part of the grid. Likewise, F is not lattice. It is only on one part of the grid. So the answer is C. We have 2 lattice points. In order to calculate slope of a line, we need to be able to see it hitting lattice points. Remember, a line has an infinite number of points, but only a few of them are going to be lattice. This line has lattice here, here, and here. So the answer to number 21 is D. We have 3 lattice points. We can use these lattice points to calculate the slope of line L. If we walk Steve from lattice point to lattice point, he goes up 1 and right 3 to create a slope ratio of +1/3. Number 23, how many lattice points does line L intercept on this grid? We should be able to identify this. That's 1, 2, 3, 4, and finally 5. The answer for number 23 is F. Number 24 and last problem of the day, which always makes me really sad because I'm going to miss every one. What is the slope of line L? We want to use 2 of the 5 lattice points that we just found to calculate this slope. Let's use this one and this one. If we start right here, the vertical change in direction is -4. The horizontal change in direction is +2. The slope of a line is the ratio of its vertical change to its horizontal change from any 2 points. -4 divided by +2 is -2c. Everybody, I had a whole lot of fun today talking about the slope of a line with you, and I can't wait for part 2.